Oh, you're gonna know very soon what it's all
Are we going
about.
to cut and eat it?
आपसे question है.
Are we going to cut
What is
it?
antimatter?
Because if we're going to cut it,
We're
I'm
gonna
going to
come
like
to
it.
that
because
later.
in my
Okay,
home,
guys,
I
look.
love
Today we are going to talk about atoms. Now, what are atoms?
Don't know. Is
We
that
don't. No. I want to. Shh. You're going to listen to me and only speak when I ask you a question. Okay, so let's start 2,500 years ago. Can you imagine how long a time ago that was? 2,500 years ago. Now, just to put things in the right picture.
when dinosaurs used to exist?
No, dinosaurs were way before that.
Yeah.
It was like
1,000.
No talking. Otherwise, we won't get anywhere. Okay, so 2,500 years, you are 10 years old or 15 years old, or that's it. I am 74 years old. Oh, yeah. Prophet Muhammad was born 1,500 years ago. 1,000 years before that is 2,500 years. And that's the time that people started wondering what happens if you cut an apple and
Nothing happened. You just
can I have the table?
That knife looks scary.
Acha. So here is an apple. Check. What happened?
It died.
I cut it in two.
It died. Knife
No, it didn't die. Well, now what will happen?
We will eat it.
4 pieces. 3.
I have 1/4 of an apple. What happens? 1/8. What happens now?
Are you going to crush them to juice?
1/16. What happens now?
Be careful.
1/32. 1/32.
You're not cutting that again.
Oh, he is.
What happens now? You tell me.
You're
One-
gonna lose your, you're
1
gonna
over?
lose your, you're gonna lose your finger. That's gonna happen now.
1/64.
Apple is very
All right. What happens now? 1/128. What happens now? 1/256. What happens now?
You're going to cut your finger.
What happens now?
cutting because you're gonna
1/512. And
Going to cut your finger.
all right, now I'm going to keep cutting and keep cutting. Now the problem is that this knife isn't sharp enough. And these pieces have got too small. So what should I do?
Sharp the knife.
Get a sharper knife. Very good.
Don't stab me.
Now, okay, I will get a sharper knife and I will keep cutting and cutting and cutting and cutting.
and you will be all gone.
No, the apple will still be there because cut, cut. Now, my question is, will I be cutting and cutting forever? Or will this ever stop?
Yes.
It will stop if we turn it into a juice and throw it in the dustbin.
Wrong
Or it will
answer.
happen if we eat it all.
Wrong answer. Will it answer my question?
No.
Will it? Can I keep cutting and cutting and cutting and cutting?
No.
How do you know?
Because it's going to stop at one point.
Why? How do you
Not
know?
gonna stop because
So this is a question whose answer, look, very smart people. His name was Democritus. He was a Greek philosopher 2,500 years ago who said, well, let's assume that it stops and that there is a smallest part of the apple.
That's a
Let's call that
An atom.
an atom of the apple. All right.
There's also something.
So
smaller
if
than atom.
if it stops, then we reach the atom of an apple.
Is this an atom?
What about
That's a seed.
Carrot.
a carrot? All right, let's do the same with a carrot.
I like cutting things.
All right,
I want to cut.
half.
I want to eat the apple. How else are we supposed to
We'll,
cut
I'll
this?
give you some
Okay.
later, but later.
I want to eat
Stop.
carrot.
Okay.
I want to eat an onion, to be honest.
I'm cutting the carrot now. A full carrot is now a half carrot. What's it now? A quarter. What's it now? An eighth. What's it now? A 16th. And I can keep going in. And what will I get to at the end of it all?
The atom of the carrot.
The atom of the carrot. Absolutely. Okay, now, what if I have cabbage or I have
Watermelon.
onion or anything? I'll
Watermelon. You can never.
and I no, इसको बस रहने दो, हाँ. So here is I will eventually get to the atom of this, that. The atom of a stone, the atom of a piece of wood, the atom of this, the atom of that, and how many things are there in the world?
A billion.
Many, unlimited.
Find an atom of us if you cut us.
So,
Find an atom of us. That's our heart.
so let's say I take out your teeth, okay?
Ew.
And then I cut that teeth, then I'll have an atom of your tooth.
Ew. Then if you cut from here, you'll have an atom of my heart.
That's true. So, you get billions and billions and trillions and zillions of atoms.
What if you take a knife and cut a knife?
Look.
Find the atom of a knife.
Quiet. We all have to learn, okay? So you cannot interrupt. That's bad manners. Okay? So then you get so many different atoms and it makes no sense at all. And so it was a big leap. Now I'm not going to tell you how that big leap was made, but it turns out a big leap in thinking. It turns out that there are only a few different kinds of atoms, and they are called atoms of different elements. So there's an atom of hydrogen, there's an atom of helium, there's an atom of oxygen, there's an atom of carbon
Dioxide.
not carbon dioxide, that's something different, we'll come to that. There's an atom of something like only 90 elements, only 90, and everything is made up of these atoms.
Just in different arrangements.
And so, yeah.
Sir, when the Big Bang happened, like you said, atoms, they are a type of matter. So the scientists thought that with matter came antimatter.
Yeah, well, there is such a thing as an anti-atom, but maybe we'll come to that later, okay? Because first we have to understand some things about atoms. So, it turns out that there are only a few different atoms, and each atom corresponds to a different element. Now, the thing is that these atoms can make friends with each other. You see, just like you can make friends with her or her or her,
We are.
you are friends. All right. Are there? So now, everything that we see around us, you know, you talked of carbon dioxide, that's carbon making a friend with an oxygen
What?
and another oxygen.
What?
Yes.
What?
Yes.
There is water. What is water?
Liquid. What's
Two hydrogens and one oxygen. So the oxygen makes a friend with one hydrogen here, and that's a water molecule. I'm a water molecule. And then there are atoms which make no friends at all.
Lonely.
Alam,
Apples and carrots.
इसका हाथ बांध दो, इसके so दोनों हाथ बांध लो. Okay, you want to have your hands tied? Okay.
Yes, I want to.
Now here's a guy who makes no friends. इसके हाथ बांध दो.
Please. Yeah, that is considered like kidnapping.
Stand up so that we can see you.
I want my hand to be tied up.
Getting jailed.
I want
Okay.
my hand to be tied up. Yeah, same. Why are you tying up?
I'll tell you why I'm tying his hands.
Cuts his hands.
Yeah, literally cut it. Yeah, cut
मैं
it.
समझे ये
Okay.
punishment है.
Now here's a guy who makes no bonds, who makes no friends, and he has
Exactly.
zero valency. So here's a new word for you. Alam likh lo. VAL.
ANCY.
VALENCY. Valency. So he is zero valency. Okay. Now we need someone with one valency. Okay. Up.
Can I? We all are a group.
By one hand.
One hand.
हाँ इधर
I wanted to do it.
हाँ कमर के साथ ऐसे.
I wanted to do it.
Yeah.
Me want to do it. I also
Okay.
want to do it. Can I?
And I also need.
Can I do it?
And I,
Me.
now you see,
Me, I really wanted to.
try making friends with him. Try.
How?
Well, put out one hand, but he can't get up.
Yes,
He can't make friends with you
Yeah, I know. I know.
because he is zero valency and you
Just
are
do this.
one valency. Stick out your hand. Stick out your hand. Yeah, go close to him. Go close to him.
Few. I'm
नजदीक
happy
आओ
I
ना.
didn't-
Try,
I'm
try.
happy he didn't pick me.
Yeah, they can't make friends with each other because she is one. She is valency 1. He is valency 0. Okay. Now, madam, you are hydrogen. Your name is hydrogen. Let's get another hydrogen. इसका भी हाथ बांध दो.
Can I? Me. Can I?
एक हाथ बांध.
Why does it have to be this?
Okay. Now try and make friends with her. Yeah. Okay. So. Yeah.
Oh, I'm not yet. Stay like that.
Wait. So what are we going to call this couple?
Couple?
Hydrogen.
Ah, lovely. That's a molecule of hydrogen. Do it again. Yeah, or dance, do something. Yeah. So that's a molecule of hydrogen.
And that's a new.
And you see it's valency, one bond and one bond. Come on. Okay. Good. Right. Now I need somebody with two hands. How many? Oh, you okay? You have two hands? Okay.
I have two hands.
So come here. In between them.
Oh no. You're not
And
doing that.
you are Mr. Oxygen.
Mr.
So and join up with him. And what should we call?
A family.
Hey. No, it's the oxygen family. It's oxygen. This is oxygen. This is water then. So hydrogen, oxygen, hydrogen. That's H2O.
H2O.
Okay. यार ये कुछ AC चला लो. So you see, okay, now you can take that off.
I don't want to
You
pick
can-
it up. I don't know. I don't want to. I want to swim to like it. Me too.
Okay. Now, what you saw was that oxygen can make
Friends.
oxygen can make two friends, hydrogen can make only one friend, and this is how we made the simplest kind of molecule.
And what about?
And that molecule was water. Now, there's one element which is responsible for all this stuff over here.
Carbon.
And that is carbon. You said carbon.
He
Carbon,
forgot to untie his hands.
carbon is going to be a little difficult for us to imagine because carbon has 4 friends. Carbon has valency 4. Okay, right over here. Acha,
I have one.
this guy was helium. He was also neon. He was also argon. He was also krypton.
All the like noble gases.
Yeah, so he's a very noble man.
Very noble.
So, but a noble man makes no friends. That's the point.
Sad. So sad.
On the other hand, Miss Oxygen, you are also Miss Oxygen. They make friends, one friend only,
Miss Oxygen.
and oxygen makes 2 friends, but carbon makes 4 friends. Now, here is the problem. Guys, think about this. You have only 2 hands.
Yeah.
So we can do like this.
Like what?
Like this.
See, I need to make.
Everyone hold.
I need someone who can think of making 4 friends.
Everyone be holding each other.
Yeah, but you have only 2 hands. I need somebody with 4 hands.
What?
Yeah.
That's not even humanly possible. I know.
I
My feet and
know.
my hands can help.
Okay, so you get up.
No.
Up. No, up.
And I'll.
And you get up
Me too.
and you stand back to back. Back to back. Oh, इसके पीछे है इधर.
What? Where?
Oh, come here. All right, like this. Now raise your hand. Put your hands out like this. Don't catch them. And the other. Okay. So now I have 4 hands.
Carbon.
Yay.
Now catch one hand. You catch one hand, and I need. Yes, you catch this hand, and I. And so, what do I have?
Both of you.
Okay, so here these 2 are 1 atom of carbon. This is 1 atom of carbon. Here's hydrogen, there's hydrogen, and there's hydrogen. So what is this? Carbon and 4 atoms of hydrogen. This is, now okay, you can sit down. This is a gas
Yeah, carbon.
which is called methane. Okay. यार लिखो इधर MET METHAN.
Happened.
So isn't methane a liquid?
How to become Okay, here you
E हाँ और ये CH4 लिख लो CH4. So 1 carbon and 4 hydrogen. And have you ever smelt methane?
Yes, it smells very bad.
No.
It smells of poop.
Yeah.
Yuck.
Please no.
Okay. So that's how. Now you see, I gave you the example of methane because it's got carbon and it's got hydrogen in it. Now everything in here, in this apple, is carbon, hydrogen, oxygen, nitrogen, phosphorus, just a few elements in it. Phosphorus, like you have in matches, but it's all here. This has got maybe, I'd say, 7, 8, 9, 10 elements in it, not more than that.
Yet it is
And this is just to tell you how molecules are made, and they are made on the basis of friendship, on the basis of valency. Okay. Now, you've learned something about atoms. You've learned that they're the smallest things that you cannot divide further. You've also learned that there are a few types of atoms, and then you learned that they make friends with each other, and then they make molecules. Okay, so that's good learning.
I need that.
All right, now I need the very smart ones here to tell me. You're okay. So what is the biggest molecule that we know about?
The
Uranium.
Earth.
Yeah.
Earth.
No. I'm talking about the molecules. Which is the biggest, absolutely the biggest molecule?
Water.
You said glucose?
Humans?
Glucose is big. I mean, it's this big. But I want a molecule that if I string out, it'll be. Hey, he said it right. Now tell us about DNA. Come on,
DNA is like
stand up and tell us.
One stand over here.
Yeah, but still, it's good. It's good. Come on, up.
DNA.
Yeah.
DNA is like the programming of our cells inside our mitochondria.
Don't use big words. Just tell us simply.
It's like programming for our cells.
Blood.
I don't know what a cell is. Just tell me simply what a DNA
It's
is.
like the programming inside of us that allows us to like create energy and stuff.
Okay, look, I'll put it more simply. The DNA is just a long molecule. It's so long, it's got billions and billions and billions of atoms in it.
What?
And it's there in every cell of your body.
Means we have billions.
Trillions and zillions and killions and jillions of them. Yeah. Okay. So, that's absolutely right. That's the biggest molecule we know, but we also know other big molecules. Like sugar is a big molecule. Fats are big molecules. And if you look in here, you'll have proteins. Proteins are big molecules. So everything is made up of molecules. And what are molecules made up of? Atoms. Okay, very good. All right, now what? We will now go to the next level. We will talk about what's inside the atom. And most importantly, how did we get to know what's inside the atom? You know, when somebody says, oh, an atom is that, okay. But how do you know?
It's written over there.
Through an electronic microscope.
It's water.
Oh, let's go back into history when electron microscopes didn't exist. So let's go back. You see, I went back 2,500 years.
What? What?
I told you. What mean what? I told you that 2,500 years ago, there was this very wise man who then, said if we cut the apple, and by the way, you can have a little piece.
Can you have a
And anyone who gives a whole apple, oh, you're getting greedy, aren't you? Okay.
I want a
Whole apple.
Whole apple. I want to. But there's only two whole
Well,
apples left.
if you don't eat it, I'm going to eat it.
I want to. Give me an apple.
Okay.
I want a half of the apple.
All right, greedy guy. Okay, you can have that. Acha.
I have
So-
the carrot.
I want the carrot.
The carrot.
The most important thing in science is not what the result is, but how you came to that result. How did you know that there is such a thing as an atom? Well, it took
Textbooks.
come on, textbooks are written by humans. How did humans to know what an atom is? How many different kinds of atoms? Now I want to move completely away, and I want to ask, how do we know what's inside the atom? Is there something inside the atom, or is there not something inside the atom?
Cut the
And so,
atom. Look at the atom.
she says cut the atom. Now just think about it. Can I cut the atom with this knife?
No, not with a knife, but there are means to do it.
Yeah, but tell me now. How do I know, first of all, that there is something smaller than the atom? So let's
Ask our good
look,
friend
please. This way we won't get to learn anything, okay? We need to have discipline. When you want to ask a question, you raise your hand. When you want to make a comment, you raise your hand, and then we will learn from each other, right? Okay. So you've heard something called the electron.
Yes.
Well, have you ever seen an electron? Have you ever experienced an electron?
No. Never.
And if you have,
No. Mobile phone.
look. You will raise your hand. Yes.
Inside an atom is a core.
Look, I've never been inside an atom. I'm too big to go inside an atom. My question to you is, have you ever experienced an electron? Have you ever seen an electron?
Yes. The mobile phone is in static electricity.
Tell me about that.
It is when there is more negative charge than positive charge. So, yes, and like for example in winters when you wear a sweater or something, your hair goes up and there's like this crackle noise.
Beautiful. So, look, here is how we deduce things. So, you're brushing your hair, and you see that the comb starts attracting your hair. Your hair stands up on end. Or a better example is that of the Van de Graaff generator that you guys saw upstairs. Did you see that? Yeah? You turn it, and then you see a spark. You can also get a shock. And why is that happening? It's because electrons are moving through your body, and that's why you get a shock.
Nothing in the atom.
So that's how we got to know about electrons. Now, electrons carry a charge, you call it negative.
So like a Tesla coil, it shoots out sparks out of it.
Yeah, that's exactly the same what you saw with the Van de Graaff. The Tesla coil, the Van de Graaff, they do the same thing. What they do is they separate negative from positive charges, and that's how we know that there are charges.
Why do too many electrons kill you? You cut that.
Well, yeah.
His question, did you hear?
Yeah.
Why
Too many.
Why do too many electrons kill you? Too many electrons don't kill you.
They shock you.
It's when electrons pass through your body.
Like
Like current going through a wire. Then what happens is that your cells get damaged. You feel a shock, and if it's too big a shock, if too much current passes through your body, then you go.
You faint.
But we can also use that.
More. It can be even worse than that.
You die.
Yes.
Yeah, you
But
might
if you're
definitely
standing
die. Or you might damage your cells.
But if you're standing on metal, the electricity will just pass through you. Because if, as we are a conductor and like this carpet is not, if electricity comes through me, it will bounce back. So I'll get a shock. If something beneath me is metal, then it will pass through.
Okay, that's a different issue, but the point is that if current passes through your body, then we will only pray for you.
The carpet, then the current will not pass through. That's why when you're doing work with electricity, you are advised to wear rubber shoes so that the current does not pass through.
yes. So it stays in you.
Yeah, because current will pass through metal, but it will not pass through rubber. Okay, so we know now about negative charges. That's the electron. But if you take this, does it have any net charge on it? No. Somehow all the negative charges and the positive charges cancel out. Which means that if I think of an atom as a blob, blob means okay. So can you, Aksa, you draw a blob? Yeah, just draw a blob.
What What's she drawing?
Blob man.
She's drawing a blog man.
Blob man 3000.
अच्छा ठीक है बस हो गया good that's good now sit down.
That's not
Good.
a blog. Sir,
Okay, we know. Shh. That's a nice blob. Blob is just something, right? Now this has got electrons in it, negative, but that means that there's got to be positive charges as well, right?
what was that?
And so the thought is that maybe over here at the center, maybe there's positive charge
Write a blog man.
that's spread all around. And it's like in a pudding. In a pudding where you have raisins. Raisins को क्या कहते हैं? किशमिश ना? Kishmish. So, have you eaten pudding with pudding? क्या वो फिरनी बनाते हैं या
I don't remember having any.
सवैयाँ बनाते हैं? उसमें किशमिश डालते हैं ना?
Yes.
Okay,
हम डालते हैं.
you like that?
I don't like that.
So the idea, and this is just, I'm talking of 120 years ago, very recent, 120 years ago, people thought that the atom was like a pudding with raisins in it. The raisins are, so there's plus,
I made
and the rest is electrons, negative.
I made electricity in there.
And so the positive charge and the negative charges cancel each other out, but the positive charges are just floating around here, there, like that. That was called the plum pudding model of the atom. Plum pudding model.
Plum pudding 3000.
I'm putting
तो ये ख्याल था ना कि एटम जो है वो एक पुडिंग की तरह है. It doesn't look like that at all.
But pudding to khas.
Yeah, I don't know who made that.
लेकिन you also eat atoms, by the way. You can eat an atom. What do you think you do when you eat this?
It's an atom.
You eat atoms, of course you eat atoms. अच्छा बैठ जाओ.
We can't eat the carrot, it's not a wash.
Now, what is our present understanding of the atom? That it has positive charge at the center, and the electrons go around it. Now I want to tell you how we arrived at that. So this is by a scientist by the name of Rutherford. यार ये लिख लो, RUTHER. The scientist's name was
You missed all the plants.
RUTHERFORD. He also became he then became known as Lord Rutherford. So
Mark Rutherford.
Lord
Rutherford.
Rutherford. अंग्रेजी में ना फोर्ड को फर्ड पढ़ते हैं. Rutherford. Yeah, that's the proper pronunciation. Okay, now I'll tell you how he did it.
Did he fight Priam?
Yes, he was Batman.
So, what do you do when you want to find out what do you do in order to find out what something is made of?
It's mega.
You do an experiment.
You know?
So how do you do an experiment? Well, you try to see it. How do I see this, by the way?
With your eyes.
Yeah, I know with my eyes, but what do I use in order to see this?
Glasses.
What do I use in order, what particle?
Light.
Who said light?
Me.
Good. How?
The light bounces off of it into our eyes.
Correct, absolutely. So the light from there hits this, comes into my eyes. If I turn off all the lights in this room, will I be able to see this? No.
Everything will be done.
Yeah, so we always need some particle in order to see something else. So what did Lord Rutherford do?
He fought crime.
Light off of really small things.
He didn't bounce light off, he did something else. He bounced off very small particles which are called alpha particles.
Helium plus
Alpha likh lo, A-L
PHA.
P-H-A, alpha particles. Particles.
What are they?
particles.
Particles, but bigger.
Particle L-E, particle,
With 40.
हाँ A नहीं है,
Comes with
particle नहीं, P-A-R-T-I-C-L-E.
CLE. Okay. Forget this.
Forget this.
PARTICLE.
बिल्कुल ठीक, हाँ. So these alpha particles, they go hit the atom, and Rutherford said, well, he just expected them to go straight through the atom. They're smaller than the atom, and he just expected that these would go straight through.
But it didn't.
But when he looked at the results, he found that some of the alpha particles were bouncing back to where they had been sent. So, I'm throwing this at you.
At me.
And if I throw it fast enough, it'll go straight through you. But to his great astonishment, this particle came bouncing back. Wow, he said, ye kaise ho sakta?
Yeah.
And I'll quote you his words. He says, this is as astonishing as my throwing a cannonball at a sheet of paper, and instead of going through the sheet of paper, it comes back. And he said, wow. And that was the discovery of the nucleus. That
nucleus.
at the center of the atom, there is a very heavy nucleus, and so when the alpha particle goes and hits it, it bounces back. So this is completely opposite to the plum pudding model of the atom. In the plum pudding model, there are, the positive, negative charges, they're all moving around with each other, they're dancing with each other. But here, there is a center and a very, very small center. Now I got to tell you something, guys. So, you have this picture over here. Let's say that we are here at the black hole, and you are in the black hole.
How will we escape?
Oh, yaar, suno na.
Through a white hole.
There's a white
So we are in the black hole, and we are asking, where is the nearest electron? See, there are lots of electrons going around like this.
That's electron.
But where is the nearest electron?
There. There.
You know where it is? How far it is from here? It's
2 million.
no. It's how far Behria town is here? Or
Down to 1 hour. 1 hour.
yeah, it takes you 1 hour to drive. So the nearest electron is that far away. So if you think of
It takes 1 hour to get here.
if you think of the
The electron from the nucleus?
yeah. So let me repeat this. Suppose that the nucleus was of about the size of a football. Then the nearest electron will be Behria town or the motorway or no, not as far as Lahore, but as far as the Margalas from here. So that means what? What does that mean?
The electrons are quite far away.
Yeah, but what does that mean? कोई मुझे बताए कि उसका मतलब क्या है? Can you explain this simply to me?
That
Hey, smart guy, tell me.
this means that electron is actually not. Somebody's hiding over there.
It's
Somebody's hiding.
अच्छा,
That guy is hiding. He's not.
अच्छा, shh. Seriously, I need an answer to this question.
What?
If the nearest electron is so far away, then what can I say about the atom?
The atom is very far away.
Atom is a country far away.
No. What can tell me what this says?
This atom.
This got lots of atoms in it. What does it say? Come on, tell me something.
it's like quite big.
No, what it says is, yeah.
That nucleus attracts the electrons to revolve around in an orbit.
Yeah, but the nearest electron is so far away. So what's in between?
It's like the universe, our solar system.
There is space.
Yeah, there's space. Yeah. So an atom, in other words, is nearly empty.
Nothing. It's clearly empty.
An atom is nearly empty. There's just the core, which is the nucleus, and around the nucleus there are these electrons, but the atom is mostly empty. Now, if you were to take all the empty space away, suppose I had this volume of atoms with all the empty spaces taken away. You know how much this would weigh?
How much? 2 kilometers.
To begin,
The size, it would weigh the mass of the earth.
What?
Yeah.
That's why everything is so light.
That's why everything is so light, because the atom is mostly empty space.
So the same is like about.
And just to put things in perspective, you know how heavy the electron is compared to the nucleus?
It is like it's so little weight that it's basically ignorable.
Yes, it's so think of an elephant. The elephant is the nucleus, and around it are buzzing flies and mosquitoes.
And bees.
Compare a mosquito with an elephant.
Yeah, the elephant is big and the mosquito is small. It's heavy and
The
mosquito is like a little tiny piece of.
So the mosquitoes are tiny. The mosquitoes are the electrons. The elephant is the nucleus. How do you like that?
Wow.
And if you were to take all the empty space away, you'd get an incredibly dense nucleus.
the sun is the nucleus,
Stars are
then
so
the
heavy. All the
Then the
gas
germ is
gone.
the.
So, but before we leave. So, you know, there are stars which are called neutron stars. And those neutron stars, if you were to take a neutron star which is the size of our, which has the same mass as our sun, it would be a billion times smaller. So you,
It's like more dense.
very, 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 very dense. Yeah.
Like a black hole.
Okay. Now will somebody summarize, because we need to wrap up now. Will somebody summarize what we have learned today about atoms? So
I've learned the structure.
wait. I need to.
We have learned that oxygen.
Yeah.
That,
So stand up and tell us.
that.
Acha. So start with, we have today learned that, and then you continue. Up.
We have learned that oxygen has 2 valency and oxygen has 1.
Carbon has 4,
and
hydrogen has 1,
hydrogen has 1 and
And who was the fellow who didn't make any friends?
Me.
Oh, yeah, there he is. What's his name?
Nobody even noticed him because he has no friends.
He is helium.
Helium.
He is helium
Zero element.
or neon or argon or krypton. Yeah.
Zero element.
Okay. Somebody else? Okay, you get up and tell us what we've learned.
No, I'm not telling. I want to get up.
Tell us.
Because I'm tired of sitting.
We learned that there's a lot of empty space in the atoms, which makes everything
never
lighter
sit
than
forever.
what it could be. If there wasn't so much empty space, everything would weigh a lot. Like
Okay. And you can now get up and tell us what you learned. You don't want to tell us.
She wants to tell she
Oh, yeah. Okay. Up.
I said no.
Up. Yeah, bolo.
But she just makes it.
What did you learn today?
Today we learned about atoms.
Yeah.
People first thought that atoms were similar to like puddings.
Okay. Good. And so are atoms like pudding? So what are they like? Like that. Good. And how did we know? How did we know?
Because the electrons, we can feel them because they are.
No. How did we? My question is, how did we know? Hint.
Because of the Rutherford experiment.
Good.
Because when he shot some alpha particles and the atoms, they bounced back. Like,
Good.
and he said that it was supposed to be like a cannonball going to be thrown into the paper, but instead it came back.
Very good. She said it very accurately.
Accurate means correct.
Accurate means on the dot. Precise. Yeah. Okay, so we are done. And I think we had fun.
And we're going to be tied together for the whole day.